Hello everybody. I'm going to talk to you about our grey-headed flying foxes that are no more than about 400 metres from here. What the heck are they doing in Adelaide, and looking at the ecological and the disease implications of these flying foxes in our area. So are they intruders or natural movers? They started to appear in 2009 into the Botanic Gardens, and then Fullerton Road, you may have heard information on the news about a colony that had arrived in a lady's backyard. They arrived again, or moved off and came back into the Botanic Gardens, and then they were shifted from there into the Botanic Park, so just adjacent to the zoo entrance. Over the period of time since they've been here, they've suffered through some heat stress events, so a lot of the recruitment of the population has not occurred because many of the pups have died. This year, however, it wasn't too much of a problem. So population in November 2014 was about 3,200. Now it's around about 4,000. So where have they come from? They live along the east coast up towards the top end of Queensland, right down into New South Wales and into Victoria. Populations, large populations in these areas, and now they've kind of made Adelaide their home. We've also got flying foxes, the black flying fox, Pteropus electo, and the little red flying fox that go across the top end of Australia. But we just see the grey-headed flying foxes down here. So why have they come? Well, are they responding to changes in the environment? Peggy Ebby, who's a prominent flying fox ecologist, says that, or believes that these are movements are consistent with some of the known behavioural responses to food shortages that are seen in any other parts of Australia. So these are records of flying foxes in new locations in 2010, new campsites in green, unusual occupation in yellow, and some new camps that formed during that 2010 period and have persisted. So there's persistence that's occurred. So seeing that they are moving into different areas and occurring. So let's talk a little bit about the grey-headed flying fox, Pteropus poliocephalus. They're protected under the National Parks and Wildlife Act of South Australia and listed as vulnerable under the EBPC Act of 1999. The camps appear to be chaotic, but in fact are highly structured, and they are known to eat over 100 species of native trees and plenty of introduced species. And they live in this really complex foraging landscape. Annual cycle is that they give birth in October, November time. The lactation periods for around about 5 months. And then breeding occurs around about April or May, a gestation period through to October and November, producing one offspring per year, normally from about 3 years of age. So they're colonial animals, and also seed dispersers, and also pollen dispersers as well. The populations are not cohesive groups. The movements of these individuals may vary, different times, through different distance, at different frequencies, go over to different places, and the fidelity to sites might change completely. There's no evidence of long-term group structure. There appears to be some adults that might stay in one area, but there'll be lots of movement between lots of the camps throughout the country. Bats are also hosts of pathogens. They have a wide geographical distribution and have this very high mobility, ability to move, and these make them ideal vectors for a bunch of different pathogens. And we can see here where the flying foxes are around the world, the different species. And they're implicated as a reservoir for many emerging infectious diseases. They're natural reservoirs, and they're very capable of harboring many pathogens without actually causing any ill effects, but are known to infect other susceptible species. Well, there's one disease, bat lyssavirus, or any of the lyssaviruses that might cause disease in bats. Most of the viruses, they do just harbour the pathogen and not get sick. So there's a whole bunch of pathogens. Some of them are present in Australia and some are not present. Some of the species or the diseases and viruses that are present here are the Menangle virus that caused an outbreak of abortion in pigs in New South Wales in the 90s. Hendra virus, of course, which you may have heard of, has caused disease in New South Wales and Queensland, in particular in horses, over 70 cases and a few people have been infected. Australian bat lyssavirus has caused death in 3 people. And then there's other paramyxoviruses, other Hendra-like viruses that they've been being picked up as well. But we're not present in Australia, thankfully, are diseases like Nipah virus, filoviruses like Ebola, MERS, Middle Eastern Respiratory Syndrome, and acute respiratory syndrome that occurred in 2000s in Hong Kong, and then hantavirus and reoviruses. So we've got a whole bunch of viruses that we don't think are here, but we're not too sure. So part of my work is to look at my research is, as a PhD student, is to do some modelling of Hendra virus in the bats, along with Australian bat lyssavirus, looking at the epidemiology, looking at a population viability analysis of grey-headed flying foxes within Australia, not just in South Australia. Look at a species distribution model of flying fox species in Australia, and look at some of the virus prevalence in urine, in the urine and in the serum of some of the bats that we're catching. Also looking at spatial movements and the ecology of these grey-headed flying foxes. And so we've had this opportunity to put on some radio tracking or satellite tracking collars. So we want to determine what movements, what the habitat use is, and what food resources they are using. So we're using solar-powered GPS collars in conjunction with CSIRO. There's the solar-powered collar on a flying fox. They collect data during the day and download through GSM network to a base station, which is next to in the botanic parks. And using the CSIRO software, we're able to quantify patterns of movement and where they're moving, foraging sites, including specific trees that they might be eating. So here's some of the data that we've got from this, and it's really quite interesting. We put on 5 collars in September. 1 didn't work. 4 collected some data. This was over a 2-month period until the collars fell off. And with each of these animals, they tended to individuals move in the similar sort of direction each time during that period. So they take routes that they know of, go and find food, come back to the camp early in the morning. So very sort of rigid movements. Occasionally they might go AWOL, go for a bit of a wander, might go on holiday. Sometimes they might go to the beach and have a bit of a drink at do a bit of sunbathing at night. Of course you can't do that, but they actually go and do some drinking, we've noticed, and I'll show you that a little bit. This is some of the information here so that we've got. So this is where the camp is, and this is the coat hanger, and this is the movement of some of the bats going across the landscape. Oh, and for some reason I've slipped in a slide here accidentally. With the Hendra virus prevalence and seroprevalence and virus discovery, we're trapping some of these flying foxes, and twice a year using mist nets, and we're going to anaesthetize them. We've anaesthetized a whole bunch, about up to 100 so far. We're looking at the seroprevalence, which means the amount of antibodies in the blood of Hendra virus and bat lyssavirus and other diseases, and also checking from PCRs what they are shedding in the urine and what might be in the blood as well. So we catch them in nets underneath the colony with the help of a big crew. That slide slipped in somehow. I don't know how I missed it, but it was supposed to be earlier on. So this is some of the movements. They actually fly by the Adelaide Oval to see if there's any cricket on or some footy, and go following tracks often over the golf course and along riverbanks and streams and into gardens. So they're eating in lots of different places, gardens, taking exotic food, and we're seeing that some of them have actually gone down to Henley Beach and gone for a dip. We think we're drinking some water there, might be to get some more salt. So what we're finding is that they're eating, at this particular time, they're eating the flowering plants that are exotic to South Australia, that are flowering in this time of the year. So we looked at September, October, November, and they're also eating olives, and they're eating date palms, and, as well as these exotic gum trees. They're exotic to South Australia. So that's a little snapshot of what we're doing at the moment. I hope to get more data shortly, and I just wanted to say thank you to some of the guys that have been helping over and above my supervisors and collaborators here. Thank you.
Anyone have any questions for Wayne? Up the back.
Yes, so you talked about how you were testing for the various viruses and so on. So have you found any of the deadly ones for humans in Adelaide or not?
We have found from post-mortem samples Hendra virus and Hendra-like virus, which is not been typed yet, so we don't know how pathogenic that particular virus is. We are still yet to do some of the testing on the samples that we've taken, but previously we've done quite a few post-mortems on flying foxes, fresh flying foxes that have been found dead that have been post-mortemed up at the vet school.
Okay, and how then is the method of the viruses transmitted to humans?
Normally, particularly Hendra virus, that's where there's been some evidence of spillover, it spills over to horses. So where flying foxes, particularly the black flying foxes, where there's much more evidence for shedding of the virus in the urine, where they go to feed at night may be near where horses are. And if the horses pick up the scats or the urine where they've dropped the urine, that's when the virus might be in that material. And then it, over a few days, incubates, causes disease in the horses, and then people then get the disease if they go and look after those horses that might be sick.
Man in the red shirt up the back.
This colony is several hundred kilometres from the nearest known colony. Is there any interchange between the animals in this colony and those in Western Victoria, which is the nearest colony, I guess? Or was it one batch that just came across on the...
We're not too sure, Bill. We certainly know that they've come over in small groups to begin with, what make them come over, looking probably for food. But we do know that they can travel up to 700 or 800 kilometres a day, particularly going from west to east. They go very high and they can travel big distances. So we know that they can go backwards and forwards, and they may well be going back into these camps in New South Wales. Originally, when Terry Reardon and Peggy Ebby looked at those bats that were radio tracked, that were moved from the gardens to the park, they put some radio tracking collars on them, and Peggy found one radio track collar bat in Bateman's Bay 2 weeks later.
Wow. All right, we might leave it there.
Thank you.
Thanks very much.